Hello logic friends. Have you ever wondered how computers process decisions, or how we can be certain that an argument is valid? The answer lies in mathematical logic. Mathematical logic has rules of the game called the laws of logic. These are the fundamental principles for simplifying and proving that two logical statements are equivalent. Imagine you want to negate the combination of two things. These laws, such as De Morgan's laws, allow us to transform that into the negation of each thing separately. This is crucial for digital circuit design and programming. But, how do we use logic to draw valid conclusions? This is where the rules of inference come in. They are the tools for building valid arguments. We start with premises, and these rules help us step toward a certain conclusion. The most common rule is modus ponens. Also known as affirming the antecedent, is a logical argument form that states if a conditional statement, if X is true then Y is true and its antecedent, X, is affirmed as true, then the consequent, Y, must also be true. Simply put, if P then Q. We know P is true. Therefore, Q must be true. Example. If it rains, then the road is wet. It is raining. So, the road must be wet. The second important rule is modus tollens. Is denying the consequent, is a form of logical argument stating that if a conditional statement, if X is true then Y is true and the consequent, Y, is false, then the antecedent, X, must also be false. If P then Q and we know not Q is true, then not P must be true. Example, if it rains, then the road is wet. The road is not wet. This means it cannot be raining. And the third, the hypothetical syllogism, a deductive argument that chains together if-then statements, where the conclusion of one premise becomes the condition for the next, is like a chain of conclusions. If P then Q, and if Q then R. Therefore, we can directly conclude if P then R. So, remember. The laws of logic help us simplify statements, while the rules of inference help us draw valid conclusions from existing statements. Mastering these two things is the key to thinking critically, solving complex problems, and even understanding the fundamentals of computer science. Thank you for watching. See you in the next logic topic.